For an object on an inclined plane, the force of gravity will act downward, mg. M is the mass, g is acceleration due to gravity, which is 9.8 meters per second square. The box is on the plane, so the motion of the box will happen along this plane. So this plane becomes our axis. We call it x. So this is x, and we know the perpendicular axis would be called y. Since the motion is happening along this axis, the x-axis, all the forces should be written in x. They should be resolved in x and y direction. mg is not acting in either x or y, so we will write the component of mg. One of the components would be mg cos theta, which is 25 degrees, and this will also be the value of normal force acting perpendicular to the surface, so along the y-axis, mg cos 25 degrees, and this is the normal force. Other component of mg would be mg sin theta, and it will act in the downward direction because mg always acts downwards. It won't act in this direction because this is going up, so that won't be a component of mg. It would be mg sin 25 degrees going this way. Now in this situation, if there are no other forces acting, then the box or the object will move downward like this. And we know that friction always acts opposite to the direction of motion. So if this is the direction of motion, then friction force would be here. But let's assume there is another force, F, acting this way. And because of this force, now the motion is happening along this direction, in the positive x direction. Since the motion happens in positive x, force of friction would be opposite to the direction of motion, force of friction, like this. And now when we write the net force, it would be net force in the x direction. It would be this force F, because it's acting in the x direction, and this force and friction force, they are both acting in the x direction but in the opposite direction. So minus, they will go with minus sign because they are in the negative direction of x. F minus mg sine 25 degrees minus force of friction, which is, force of friction is mu times force of normal, and force of normal is here. So if you plug in over here, it becomes mu times mg cos 25 degrees, where mu is the coefficient of friction. This is the equation of net force, and this would be equal to mass times acceleration in the x direction. For the second situation, mg will act downward as always. The component mg cos 60 degrees will go here, and the normal force would be mg sine 60 degrees perpendicular to the surface. The other component of mg, this is cos. The other component of mg, mg sine 60, would be acting downward like this, mg sine 60. And if there are no other forces acting, then the box is moving downward, and force of friction will be opposite to the direction of motion. Let's write the force equation in this situation. If the box is going this way, we will assume that this is our x-axis now, and this is y-axis. So the net force in x direction would be mg sine 60, because that's acting in the positive direction of x, minus force of friction, and those are the only forces acting in the x direction. So it becomes mg sine 60 degrees minus force of friction is mu times force normal. Force normal is this value. So mu times mg cos 60 degrees. This is F net in the x direction. It would be equal to mass times acceleration in the x direction. This is how you resolve all the forces along the direction of motion on an inclined plane. Hope it was helpful. If you have questions, please ask in the comment below.